Welcome back to the third day of our exponent rules. Today's rules are pretty easy. The first one is called the zero exponent. When anything has been raised to the zero power, it is always equal to 1. So this is one of those things we're just going to memorize. Any number to the zero power is equal to 1, or any quantity to the zero power. See how the whole thing is to the zero power? Our answer is 1. And in the last example, we have 4xy times 3ab, but 3ab is to the zero power. So this is really saying 4xy times 1, which is going to equal 4xy, which would equal 4xy. And that's it. So 5 to the zero power is 1. Anything over itself is 1. This third example, we have 10a squared b c to the third times negative 3 b to the 2c, all to the zero power. So that's really 10a squared b c cubed times 1, which would give us 10a squared b c cubed, or to the third power. Cubed is to the third power. Okay, the next one, we have 4x to the fourth, y to the second, z times 2, and then x to the 0, is 1, so that's like 2 times 1 times y times z to the 0 is times 1. So really, that's going to boil down to 2 times 1, 2 times 1 times y times 1, which would just give us 2y. So we have 4x to the fourth, y to the second, z times 2y. So we're going to take our 4 times our 2, because those are our whole numbers. 4 times 2, that's just normal. 4 times 2 is 8. We don't have any other x's, so we've got x to the fourth, so we've got 8x to the fourth. We have y to the second times y to the first. We add our powers. That would give us y to the third, and we don't have any other z's, so we just have z, and that's the answer to that. Okay, let's move on to negative exponents. A negative exponent, I always think of a negative exponent as just not happy because it's negative. It's not happy where it is in the fraction. So we're going to move the base and the exponent to the other side of the fraction, and then the exponent will now become positive and happy. We want everybody to be happy. So when I look at this first one, I think to myself, everything is over 1. So everything is over 1. 10 is 10 over 1. X is x over 1. This whole thing is x to the negative 2, y over 1. So I think to myself, x to the negative 2 is not very happy where it's at. So if I were to move it to the bottom of the fraction, sorry, I had to erase that. If I were to move it to the bottom of the fraction, in the bottom of the fraction, it becomes x to the positive 2. Now y is happy where it's at, so we're going to leave it in the top. Here is the next one. You see b to the negative 2. B to the negative 2 is not happy in the bottom of the fraction. So let's move it up to be with the a, and it becomes ab squared. Now the b squared's happy. Okay, and the next one, we're just shifting everybody that's not happy. We're shifting them to a different place in the fraction. So a to the negative 3 is not happy. We bring it down to the bottom of the fraction, it becomes a to the positive 3. B to the negative 5 is not happy in the top of the fraction. Bring it to the bottom of the fraction, it becomes b to the positive 5. C to the negative 1 in the top of the fraction is not happy in the top of the fraction. So bring it to the bottom, and it becomes c to the first. Now the bottom, I always just go across the top, and then I go across the bottom. So x to the negative 4 is not happy in the bottom. Bring it up to the top, and it becomes x to the positive 4. and y to the negative 2 is not happy in the bottom of the fraction. Bring it up to the top of the fraction and it becomes positive, y to the positive 2. This is z to the first. It's happy where it's at. It's already got a positive power. Leave it down there where it's at. It's happy where it's at. Okay, next problem, next example. These are power to a power. Um, so we're going to bring the whole numerator down. See how the whole thing is to the negative 2 power? If we bring it down to the bottom, now it's to the positive 2 power. And this x to the negative 5 in the bottom, it's not happy down there. Bring it up to the top and it becomes x to the positive 5. Now we can work out the power to the power and the denominator in the bottom. So my x to the 5th, I'm just bringing straight over. But here I have a powers to a power because I have parentheses with the 2 on the outside of the power. So I have to do 2 squared, which is 4. That's where the 4 comes from. I have to do x to the 3rd to the 2nd power. So that's where you multiply. When you have a power to a power, we multiply our powers. So that gives me x to the 6th. And now I have to reduce. Now I think, where do I have more x's? I have more x's in the bottom. So these 5 x's cancel out 5 of those x's. So I have 1 x left in the bottom. So I get 1 over 4x. Okay, let's try the examples. Okay, I would think of this over 1, and I would think of this over 1. Now I'm going to make everybody happy. This is 3 to the first. It's happy in the top. Leave it up in the top. A to the negative 2. It's not happy in the top. Bring it to the bottom. It becomes a to the positive 2. B to the positive 2. It's happy up there. Leave it where it's at. This is C to the positive 1. Leave it in the top. It's happy. Okay, now we'll go to the next one. The x to the 3rd, it's already in the top and it's happy. So leave it up there. Y to the negative 3, it's not happy up there. Bring it down and it becomes y to the positive 3. Z to the negative 1, it's not happy in the top of the fraction. Bring it to the bottom and it becomes z to the positive 1. And we traditionally make sure that they're in alphabetical order. B, C, X would be in order, A, Y, Z would be in order. So there we go. Done with that one. Let's move on. The 5 and the 10. That's just like a normal fraction. You would reduce that. 5 goes into 5 once, 5 goes into 10 twice. So I'm going to start my answer with the 2 in the top. My A's, I have an A and an A. A and A, they totally cancel each other out. So they're gone. Now the b to the negative 3, it's not happy in the top. Bring it down, it becomes b to the positive 3. The c to the 5th, it likes it in the top. Leave it up there in the top. C to the 5th, it's going to stay in the top. Now let's go to the bottom. B to the 2, it's happy down there. Just leave it down there. B to the positive 2. And C to the negative 2, it doesn't like it in the bottom. Bring it up. It becomes C to the positive 2. Now notice we have like bases. So we're going to clean this up just a little bit. Our 2 stays in the top. We have C to the 5th times C to the 2nd. This is where we add our powers. That would give us C to the 7. And on bottom, we have B to the 2nd times B to the 3rd. This is where we add our powers. That would give us B to the 5th. And that's done. That would be our answer. All right, the next one. So in the next one, I would take the power to the power first. That would give me m to the power of 12, negative 12. Positive 4 times the negative 3 gives me negative 12. And this is m to the negative 12 in the bottom. Well, honestly, anything over itself is 1. I know that's going to be 1, but I can redo it and I can put this m to the negative 12 doesn't like it in the top. I can bring it down and make it m to the positive 12, and the m to the negative 12 in the bottom, I can bring it up and make it m to the positive 12. M to the 12 over m to the 12 is 1, but really, truly, I knew that right here. Okay, last problem. Last problem. We've got kind of like the other problem. We've got, we're just going to reduce our whole numbers like we would normally reduce them when we were in third grade. 5 goes into 5 once, 5 goes into 10 twice. We're going to have a 2 left on top. And the m's, m to the negative 6, it's not happy up there. Bring it down and make it m to the positive 6. N to the 12, it's happy in the top. It's positive power, leave it where it's at. M to the negative 2, it's not happy in the bottom. Bring it up to the top, it becomes M to the positive 2. And N to the negative 4, it's not happy in the bottom. Bring it up to the top, and it becomes N to the positive 4. Now we're going to clean it up a little bit. 2, that's just regular old 2. In my numerator, notice in the numerator we have n to the 12th and we have n to the 4th. We can combine those. N to the 12th times n to the 4th, we'd add the powers. That would give us n to the 16th. And then we've got the m to the 2nd over m to the 6th. So we're going to reduce those. I think these two m's will cancel out 2 of those m's, and I'll have more left over in the bottom. I'll have 4 of them left in the bottom. So that would give me m to the 4. And that's it for today, guys. We're going to do exponents day 3 in Delta Math. Thanks, and have a great day.